Hello bachcho, let's read the question. So the question says light of wavelength 5000 angstrom propagating in air gets partly reflected from the surface of water. How will the wavelengths and frequencies of the reflected and refracted light be affected? So to understand the question, let us first draw a diagram. So let's suppose this is the surface of water. Here incoming air is incoming light of wavelength lambda naught is equal to 5000 angstrom. It gets partly reflected and partly refracted. The reflected ray follows law of reflection, hence I is equal to R, and the refracted ray follows Snell's law, R dash. Okay, so now this is air and this is water. So we are being asked about the wavelengths and frequencies of the reflected and refracted ray. So for reflected ray, let's suppose wavelength is lambda 1 and frequency is mu 1. For the incoming ray, let's suppose frequency is mu naught, and for refracted ray, let's suppose wavelength is lambda 2 and frequency is mu 2. Now, let us first revise the key concept behind this question. So, the key concepts behind this question are: first is frequency of light depends only on the source, but not on the medium and anything else. And the second key concept behind this question is the formula for velocity of light is given by frequency into wavelength, mu into lambda. Okay, and the third thing is that the velocity of light in a medium is given inversely proportional to the refractive index of the medium. From here, we can imply that V1 upon V2 when given two mediums will be equal to mu2 upon mu1. Okay, so keeping these three key concepts in mind, we can proceed further for our solution part. So for solution part, what do we have? We have frequency of reflected ray will be equal to frequency of refracted ray will be equal to frequency of incoming ray. Okay, because we know that frequency does not depend on the medium. Hence, from here we can say that frequency of both the rays will be equal. And second thing that we need to find that lambda 1 upon lambda 2. We need to find lambda 1 upon lambda 2. So we can find it from the relation that V1 upon V2 will be equal to mu 2 upon mu 1. And, sorry, let me correct it. It will be equal to mu 2 upon mu 1, and V1 upon V2 are themselves mu 1 lambda 1 upon mu 2 lambda 2. From the first equation, we know that mu 1 is equal to mu 2, hence mu 1 mu 2 cancels each other out. From here we can say that lambda 1 upon lambda 2 will be equal to mu 2 upon mu 1. And we know that for air mu1 is equal to 1 and mu2 is equal to 1.33. So from here lambda 1 comes out to be equal to 1.33 times lambda 2. Okay, and lambda 1 will also be equal to lambda naught because the reflected ray is not changing its medium. So from here we can show the relation of wavelength, how wavelength changes in both the cases. I hope you understood it well. Thank you.